Hi everyone, I'm RVD and great to see you here. Welcome to your next data structure lecture. So I hope you have found my another playlist that is placement interview questions really good, and you might have liked my videos of this series as well. So today I've got the next topic of this data structure for you, and that will be the concept of circular queue. So in the previous video, we have seen the working of simple queue and also the problem with simple queue. And we've finally concluded that the problem can be solved using circular queue. So before implementing the circular queue, it'll be good to see the concept of circular queue so as to understand what all the different conditions we would be working with. Fine, so let us start. So this is basically the concept of circular queue we obviously try to visualize. As I said, we have to join the front end with the rear end. So again, if you take our small example of like max equal to 4, after 0, 1, 2, 3, I obviously should go back to 0. So virtually, I actually should have my front and rear getting connected. But as you know, this is not possible physically. So what we would be having is something like this. Okay, so what we want is after 0, we should have 1, after 1, 2, after 2, 3, and after 3, or maybe in general after max minus 1, I should be going back to 0. So logically, we have to create this particular illusion. Fine, so I hope you understood the concept. Let's move on to the conditions. So let's see how can we get the circular queue conditions. Okay, now the problem is, if you have seen in the previous figure, okay, or let me show you that figure again. You can see the condition for queue empty is conflicting with the condition of queue being full. Don't you think at the current point your queue is empty? It could have been full if the slots would have contained the elements. And that's the first problem. That is conflict in the queue full and queue empty condition. And that's the reason we cannot rely upon your front and rear pointers to decide when the queue is full and when it is empty. Fine, so we have to adopt some other mechanism. Now again, there are a variety of mechanisms we can adopt to implement the circular queue. We are going ahead with the mechanism of count. So we will be having an extra field called count, which we will be using to count the number of elements of the queue. Now it's very obvious that if at all I want to use the count to decide the empty and full condition, it will be our responsibility to maintain the count. And that's the reason in insert operation, we have to increment the count because we will be adding one element into the queue. Whereas in the delete operation, we have to decrement the count. And if at all we do it properly, then I'll be able to make use of count for deciding the empty queue and full queue conditions, which will be like this. So condition for empty queue obviously will be count equal to 0, and condition for queue full will be count equal to max. Now do not get confused. It is not count equal to max minus 1, but it is count equal to max, because count is number of elements. For example, if my max is let's say 4, I generally have my indices from 0 to 3. But I would say my queue is full only when the count is equal to 4, which is equal to max. So that's the reason the count equal to max happens to be the condition for your queue being full. Now the next point is how exactly we are going to achieve this circular behavior. Because as I said, physically it's not possible to join front and rear. So we will be making use of the modulus concept. You people know modulus operator, that is the remainder operator. So that remainder operator can be used to get this circular behavior. Now the idea is every time when you increment, let's say front as well as rear, do not increment it just by +1. You have to do +1 and then mod max. Okay, so what will be the effect of that? See, in insert operation, you will increment R using the modulus operator and then you will insert. So it will be like R equal to R plus 1 mod max, and that R plus 1 in bracket is required because otherwise mod has got higher precedence. We don't want that. Now what that will happen, again if you visualize a queue with max equal to 4, it will be 0 to 3. So if it is at 0, it will be incremented to 1, and mod 4 still will be 1. 1 will go to 2 only, 2 will go to 3 only. But suppose my, let's say, R is at max minus 1. That is, if it is at 3, then 3 plus 1, 4, mod 4 will obviously go back to 0. And that is how we will be achieving the circular behavior. Isn't it the same concept we require to apply for delete operation also? So whenever we will be having a deletion from front, generally we pick up the element at F and we increment F. So again, that increment should not be a simple increment. It should be increment using modulus. So F is equal to F plus 1 in bracket mod max. Fine. So that is how we would be achieving the circular behavior. Fine. So we have understood two important points. First of all, we will not be relying upon F and R for checking Q full and Q empty. So we will be adopting extra concept of count. Okay, so insert and delete will take care of maintaining the count so that we can use count for checking for the conditions of full and empty. Along with that, we have understood that modulus operator will be used for getting that circular behavior. Fine. So whenever we'll increment F and R, we'll make it a point that we will increment using modulus operator. That is by always doing mod max. Fine. So these are the conditions which all of us need to be very clear with, so that we can very well implement the circular queue. Okay. So as far as the circular queue conditions are concerned, or a concept of circular queue is concerned, I hope you have understood it clearly. So that's it for this lecture. In the next lecture, we are going to implement the circular queue, and then we will execute and we'll see with the variety of inputs. Fine. By the time you do see the other videos which I have already posted, so that we'll be able to get a flow of all the topics of data structure if you have not seen those videos yet. And again, if you have not subscribed my channel yet, you can very well subscribe using the subscribe button which is down there, so that you can get alerts for my new videos which will be on the further topics of data structure. Fine. But currently for this video, that's it. Thank you and happy learning.